steel BB of mass m is shot from an air rifle and strikes horizontally with speed v an initially stationary steel block of mass m. It collides elastically and bounces off horizontally. The mass of the block is much larger than that of the BB. The block hangs by a rope like a pendulum and, as a result of the collision, swings and reaches a maximum height h. Part A, which statement best describes this collision as compared to other types of collision? Since the collision is elastic, kinetic energy is conserved, and that's very unusual, so that's the most important feature. Part B, what is true about the speed at which the BB bounces off the block? If kinetic energy is going to be conserved and the block's mass is much larger than the BB's mass, the momentum transferred to the block won't require much kinetic energy because Ke is P block squared over 2m block. The BB keeps most of its initial kinetic energy, so it bounces off with approximately the same speed as it had initially. Part C, now imagine that the BB is shot at twice the original speed. What happens to the potential energy gained by the block at maximum height? The momentum transfer is going to be twice as much if the initial speed is twice as much. So the Ke transferred is P squared block over 2m, or 4 times as much. The potential energy comes directly from the kinetic energy, so it's going to be 4 times as large. Part D, now consider that the BB is shot at a speed that causes the maximum height of the block to be half of what it was in the first scenario. Remember that the BB has no potential energy anywhere. If the block's potential energy is half of what it was originally, what that has to mean is that the BB is moving slower than it was originally.